Hey everyone, welcome to Chapter 10, Section 6, titled Secants, Tangents, and Angle Measures. At the top of the notes here, I have the definition of a secant. A secant is a line that intersects a circle in exactly 2 points. Lines J and K are secants of circle C. So here's circle C. You see lines J and K. They are secant lines. Basically, they're lines that go through a circle. Next, I have this Theorem 10.12. Next to it, it says, when two secants intersect inside a circle, the angles formed are related to the arcs they intercept. And so Theorem 10.12 says, if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Right, so what does all that mean? Well, you see it says measure of angle 1 is 1/2 of the measure of arc AB and measure of arc CD. So you have angle 1 here, it's intercepting arc AB, and then you're going to go opposite of angle 1, and you're going to do arc DC. So you'll add these two arc measures up, and then cut it in half. Likewise, if you wanted to figure out what angle 2 was, you'd add up arc BC plus AD, and then cut that in half. So on my first example here, I'm trying to find angle X. Well, really it's angle TVU. So really, you just need to write X equals, and you're going to do 1/2 the sum of the angles that are across from it or whatever, right? So 130 and 84. So that's going to be 1/2 of 214, and so you're going to get 107 degrees when you cut that in half. All right, on example B, we're given 143 and 75, and then we need to figure out BD and AC in order to figure out angle X here. So what I'm going to do to figure this out is I'm going to put a little Y here, and the reason why I'm going to do that is because X and Y are adjacent angles, and they form a linear pair, right? And so that means they're going to add up to 180 degrees since they share a line AD, or share a secant, I should say. And so I can figure out angle Y pretty easy here. I just need to add together 143 and 75 and divide it by 2. And so adding 143 plus 75 is going to give me 218 degrees. Cut that in half and you'll have 109 degrees. So to figure out X, we simply just need to do 180 minus 109, which is going to give me 71 degrees. On example C here, we're going to work backwards. Previously, we had the angle inside that was unknown, but now we know that it's going to be 110. So I'm going to say 110 equals 1/2 the sum of 97 plus whatever X is. So what you need to do is you got two different ways you can solve this. You can distribute the 1/2 and then solve for X. But what I like to do is, instead of distributing, I'm going to multiply both sides by 2/1, or just 2, and that'll clear out my fraction right there. And 2 times 110 is pretty easy to do. That's going to be 220 equal to, and now you don't have parentheses, 97 plus X. And so I'm just going to minus 97 to the other side. And 220 minus 97 is going to give me 123 degrees. And that's what X is. Next we have recall that Theorem 10.6 states that the measure of an inscribed angle is half the measure of its intercepted arc. If one of the sides of this angle is tangent to the circle, this relationship still holds true. So this is from a couple sections ago, but here it says measure of angle 1 is 1/2 of arc AB. So angle 1 is here, and then arc AB is there. And then measure of angle 2 is going to be half of arc BCA or ACB. So the only thing is it just looks different because now this angle has a line that's tangent to the circle. So we're going to go here and we're going to figure out angle QPR. So that's this inside angle. So this is going to be double of that. So just cut that in half, and half of 148 is going to be 74 degrees. And that's really all you have to do on this one. This one I have 64, and I'm looking for arc DEF, which is actually this arc right here. But the easiest thing to figure out first is what arc DF is, or FD is, and you just got to double that. 64 times 2 is 128, and so we just need to do 360 minus 128 here, and we'll figure out arc DEF, and 360 minus 128 is 232 degrees, so that's what DEF is. Next, I have secants and tangents can also meet outside a circle. The measure of the angle formed also involves half of the measures of the arcs they intercept. So, in Theorem 10.14, it says, if two secants, secant and a tangent, or two tangents, intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So in these three examples, I have the measure of angle A is 1/2 of arc DE minus arc BC. And that's when you have two secants intersecting through a circle. So this next example is a secant and a tangent forming an angle. And so you're going to do 1/2 of DC minus BC. So same process. And then in this one, you have two tangents forming an angle. And it's going to be 1/2 of BDC minus arc BC. For my first example, I'm going to figure out angle L. What I need to do before I figure out angle L is figure out what arc HJK is going to equal. And so that one is just 360 minus 102. And 360 minus 102 is 258 degrees. And so then I can just apply the formula. I'm going to do 1/2 of the difference of 258 minus 102. Make sure you do the big one minus the smaller one, because you never want to get a negative answer here. And that's just going to give you 78 degrees. So if you ever get a negative number, you probably just put them in the wrong order. In this case, you could get away with just writing it as a positive number. But yeah, negative angles would not make any sense for these types of problems. So my next example, the picture might be a little bit confusing. The 68 degrees is given for angle Y, and we're trying to find measure of arc XZ. So I'll just put like a little X right there. And so we're given the angle, and we need to figure out one of the arcs. So let's just set it up like the formula says. So we have 68 equal to 1/2 the difference of 224. You can tell that that's going to be bigger than arc XZ. I mean, yeah, just based on appearance, but if it's more than 180, then it's a major arc, and therefore the other arc will have to be a minor arc. So that's why I know I'm going to do 224 minus X and not X minus 224. So, like the other problem, I have 1/2. I could choose to distribute it to the 224 minus the X, or I could just multiply both sides by 2/1, or just 2. And because the reason why I say or just 2 is because 2/1 is 2. And so 2 times 168 is going to give me 136. And then I'm just left with the 224 minus the X. And so I'm going to minus the 224 to the other side. And then 136 minus 224 is going to give me negative 88. And I know what you must be saying. You're like, hey, you just said that you can't have any negative angles. But you got to look. It's equal to negative X. See, it was 224 minus X. So if you just minus the 224 over, now you have a negative X. So positive X will equal the opposite sign. The negatives will cancel each other out. Sometimes, or you could think of it as dividing both sides by -1. But for me, I just like to think of it like this. If negative X equals negative 88, then positive X equals positive 88. And so measure of arc XZ is going to equal 88 degrees. I got a couple more examples similar to the first two. Here I'm looking for angle S. So the measure of angle S, that one's just the formula one. Just do 1/2 and you have the major arc, or the bigger arc I should say, minus, since 179 is not a major arc, minus 71. And so 79 minus 71 divided by 2 is going to be 54 degrees. So measure of angle S is 54 degrees. Here I'm looking for arc CD, and I'm given that the angle DAC or CAD, whatever, is going to be 56 degrees. So I'm going to set it up saying 56 equals 1/2, and then the difference would be that outer one. So CD, we'll just put an X by it. And so we'll say X minus the inner one, 95. And so I'm not going to distribute the 1/2. It's going to be quicker to flip it and multiply it. So when you flip 1/2, it becomes 2/1, or just 2. So multiply both sides by 2. 2 times 56 is going to be 112. And so that's going to say 112 equals X minus 95. And so I'm going to add 95 over to the other side. And 112 plus 95, that's a positive number, and you notice it equals a positive X here. I don't have to flip any signs like the other one. But 112 plus 95 is going to be 207 degrees. Example 4 will be a little bit more complicated. We're going to find the value of X and the missing arcs. So what you're going to do is you're going to set it up like you were doing the other problems. You have 54 being your interior, or your I guess it's an exterior angle, and then these are your arcs. So you're going to have 54 equal to 1/2 the difference of, and so we're going to do 13x minus 6, and then I'm going to put that in parentheses because I'm subtracting out another expression of 5x plus 14. So that'll be in parentheses. And so around this whole thing will be, I guess I'll just put a bracket right here. So let's distribute this negative here. And so we're going to do, we'll turn that into a minus 5x minus 14. And I could take the parentheses away now. I have 13x minus 6, and I still have the big parentheses around it, and I'm just going to bring everything else down. And so I'm going to combine like terms. Let's see here. 13x minus 5x is going to give me 8x, and negative 6 minus 14 is going to give me negative 20. And so I have 8x minus 20, 1/2 on the outside of it, and 54. So at this point, I'd like to get rid of that 1/2. So I'm going to flip it and multiply both sides by it. So multiply both sides by 2. And so that's going to give me, let's see here, 54 times 2 is 108. And that's going to equal 8x minus 20. I'll add 20 to the other side. And 108 plus 20 is 128 equals 8x. So I'll divide both sides by 8. And 128 divided by 8 is going to give me 16 for x. So what I need to do now is just take that 16 and plug it back in. So 13 times 16 minus 6, and then I'm going to do 5 times 16 plus 14. So 13 times 16 minus 6 is 202 degrees. 5 times 16 plus 14 is 94 degrees. And so now I found x and my 2 arc measures. And so that's going to wrap it up for these notes. I hope you learned something. Thank you for watching, and goodbye.